Okay, we're going to look at factoring a difference of squares. So a difference of squares is going to look something like this. X squared minus something else squared, d squared let's call it. It could look a little bit more complicated than this. It could look something like this. Ax, or a squared x squared, and the a squared x squared is the same as ax all squared minus d squared. Okay, so it could look like this. And these both factor to look like these. So if you see this pattern here, you're going to be able to factor that quadratic so that it looks just like this. And you can do it pretty much in 1 or 2 steps. Okay, so you don't have to go through decomposition or product sum method at all for this. You can just jump right to the answer. So if we look at the build up to this, so if we expand something like x minus 3 times x plus 3, that's in this form here. X minus something, x plus that same thing. If we expand that, we get this using FOIL. X squared, that's the first. Outside is plus 3x. Inside is minus 3x. And 9 minus 9 is the last terms. These two middle terms, because these numbers are the same but opposite signs, they will always disappear. They'll equal 0. They'll cancel each other out. So you end up having x squared minus some perfect square, because that last number is the 3 times 3. It's squared. Okay? And you can write that then as a difference of squares. So that's a difference of 2 squared things. Okay? So going backwards, if you know what these two things are, you can just plug in the factoring of it right there. Okay? So more generally, if it's just x minus d, x plus d, expand that out. First term is x squared. Middle two terms are opposite signs, so outside, inside, xd minus xd. And then the last term is negative d squared. Those cancel out, and you have a difference of squares. So anytime you have something that looks like this, you can immediately factor it to x minus d, x plus d. Okay? Working backwards, so factoring it, it's basically like I just said. If you have x squared minus d squared, something that looks like that, then you can immediately factor it to x minus d, x plus d. If you had something more complex, like the ax minus d and ax plus d, so now we have a number in front of the x. When you multiply it out, you get a squared x squared, so ax times ax is a squared x squared, plus axd, the outside, minus axd, the inside, and then minus d squared, which is the last. Okay, these two terms cancel out, and you end up with ax squared minus d squared, like that. And now this is a difference of 2 squared things. So if you see something in this form, you can immediately factor it to that. Okay, so for any quadratic, basically, where you have some object squared minus some object squared, okay, so that could be an expression, could be something else more complicated. As long as there's a minus of 2 things that are squared, you can factor it to a minus b, a plus b. And those a's and b's can be anything. Okay, so let's take a look at some examples here. So for this one, c squared minus 36. Is that a difference of squares? Well, if you look at c squared, well, that's definitely a square. There's the difference. 36, is that something squared? It's 6 squared. So you can now write it as c squared minus 6 squared. That's a difference of squares. So now you can use this formula right here. Because it's a difference of squares, you can write it as that factored. Okay? So there's the solution to that. Okay, so that's factoring this, you can jump right to this answer. What about 3x squared minus 12? Well, 3 is not a perfect square, so you can't treat this like the the a squared x squared one, but what we do notice here is 3 is a common factor. So always, first thing, look for a common factor. Okay, so 3 is a common factor. Then we have here a difference of two things, 1 squared. Can we convert that to something squared? Well, it's 2 squared. And then you can factor to this. Okay, so that's the factoring of that. Now they get more complex. Okay, so what about this one here? 4k squared minus 49. Is that a difference of squares? Well, 4 is a perfect square. It's 2 squared. So you could write that as 2 times k all squared. This squared here only means that the k is squared, not the 4. If you wanted the 4 squared, you'd have to have brackets around it. Okay? So this is where the 2 is squared and the k is squared. So now we have a difference of two things that are squared. And you can write them as this, 2k minus 7, 2k plus 7. Okay, another one, 12x squared minus 75. Is there a common factor here? Because 12 is not a perfect square. Okay, so there is, it's 3. So 3 is a common factor. What do you have left over? 4x squared minus 25. Is that a difference of two squares? Well, 4x squared could be written as 2x all squared, and 25 can be written as 5 squared. So we have this difference of squares now, and we can write it as that factor. Okay. A couple more. 4x squared minus y squared. So now we don't have a number here, we just have something squared. That's fine. Can we write that as a difference of two things squared? Well, we can write it like this. 2x squared is 4x squared minus y squared. So now we have a difference of squares, and you can write it as that. Okay, the last one here. 25x squared minus 9y squared. Can you write that as a difference of two things squared? You sure can. 5x all squared is 25x squared. 3y all squared is the same as 9y squared, and there's a difference. And you can plug it into your factoring formula with a minus and a plus in between them. And that's it for difference of squares.